Welcome back to our heat transfer class, where we are delving into the phenomenon of the exchange of thermal energy between surfaces by radiation. This video was made with the support of Energy. After studying the radiant energy balances in enclosures with several surfaces, in this lesson we will focus in the particular case of enclosures with two surfaces. We will divide this lesson into several parts. The objective, as in the previous lesson, is to calculate the radiant energy absorbed or released by all the surfaces of a closed enclosure. However, in this case, for enclosures that only have two surfaces. With this, we will be able to build a simplified mathematical model to predict the heat exchange between surfaces at different temperatures by the mechanism of radiation. General case. The general case of a two-surface enclosure is limited to a system of two equations with two unknowns. Manipulating and combining equations, we arrive at an expression for net radiant heat transfer rate as a function of temperatures, emissivities, and view factors. For an enclosure with two gray surfaces, the radiation functions are simplified and disappear. In this way, it is not necessary to solve the system to find the radiosities, then the irradiances, and finally the heat transfer rates. For enclosures with two surfaces, the heat transfer rates are calculated directly. One flat or convex surface and the other concave. Starting from the general case, in enclosures where there is a flat or convex surface surrounded by a concave surface, the balance equation is simplified since the view factor of 1 to 2 is 1. When the concave surface is infinite or very large, we arrive at the calculation equation for radiation losses towards a large dimensional environment at uniform temperature. Infinite parallel planes. Another special case of two-surface enclosures is that of infinite parallel planes. Since the two areas are the same, the expression for the heat transfer rate is simplified and only depends on the temperatures and the emissivities.